There we go. Welcome everybody to Games with Go, episode 5, where we will be making a text adventure, a fully featured one this time. For people who are new, if you're interested in catching up with old episodes, you can go to the website. There's a link to past episodes there. All right, to recap, past 2 episodes, we've made some simple text adventures. We had the first one, which used a linked list. And that wasn't so exciting because the player had no choices at all. And then we had the branching story, which used a binary tree, which was better, but still pretty limiting because players only had a couple of choices at each step. And so today we're going to go to a fully featured data structure so that we can have any kind of story we want. And so what we're going to use is a graph. And a graph is just something where the nodes can have as many connections, or edges, is what we tend to call them, as you want. So if you want to have a room or something with an exit to the north, south, east, and west, you can do that. You can have 4. Or if you want to have exits that go up and down, you can do that too. Or if you want to go into the 5th dimension or back in time, you can really do anything you want because each node can have as many edges as you want to have. Let me erase real quick. Okay, and graphs are a really big topic in computer science. There are all kinds of different graphs. Graphs can be unidirectional or directional, non-directional or directional. So some graphs, when you have an edge, you can go both ways. You could go from one node to the other or back again. Other graphs are directional or directed, which means nodes have a direction, or the edges have a direction. So if you're here, you can only go that way. We're going to use a directional graph for our game, and that gives us the freedom to have a passage that's a one-way passage. Maybe you climb up and can't climb down again, or you walk through a tunnel and rocks fall and you can't go back. Anything you want to do. And if you do want to have a two-way passage, then you just have to make a second edge that points back again. Okay? And then graphs can also be cyclic or acyclic. So acyclic just means that the graph never goes back onto itself again, right? So if these were going in these directions, there's no way to go in a loop forever. However, if one node pointed back to another node, something like this would be a cyclic graph because you can go around and around and around. Our data structure will allow either kind. If you want to make a story where you can't wander around over and over in the same place, you can, but it will also allow you to have a cyclic graph. Now, while these are fun for making text adventures, there's lots of other uses for graphs. You can, for instance, like when you use Google Maps, there's probably something like a graph data structure behind the scenes, and it can use that to compute the fastest route or the shortest route for you. And there's a lot of famous algorithms for graphs. I'm going to paste some into chat here. One is Dijkstra's algorithm, and there's also a star search algorithm, which is related. And these are used for finding the shortest distance from one node to another in a graph. And there's also some famous problems in computer science related to graphs, like the traveling salesman problem, which is one that is thought to have no efficient solution, but no one has proven that yet. So maybe there is. I wouldn't try to prove it anytime soon anyway. People have been trying for years, and that's hard. All right, so let's use this graph structure to make a text adventure. All right, so let's start out. Let's make a new folder again. And let's just call it text adventure this time. Since we're going to do that for real. And I put that in the wrong spot. Drag it out to the top level. And we'll make a new file called textadventure.go. All right, we're going to have a package main, func main as always. Okay, so we need to be able to represent nodes in our text adventure that can have any number of edges on them, or any number of connections to other nodes. So we're going to start with a story node. So we'll make a struct, and this will have text as part of it, just like we've done for the other ones. But now right here, we need to have as many nodes as we want, or no nodes at all, for instance. So what we can actually do is use the linked list concept that we learned earlier inside of our story node, because a linked list could have 0 items in it or 1,000 items in it, as many as you want. So what we'll do here is we're going to make a new struct that is a linked list. We could call this, let's call it choice or choices. And then each choice will have a pointer to the next choice. So something like this. Now we want the player to have to be able to see what the choices are. So we'll need to have a description that's a string. And I'm also going to have a command. So the command is going to be what the player actually types to choose this particular choice. And then the last thing we need is each choice is going to take us to a new node in our graph. So this will be the node that we point to, and that will be a pointer to a story node. Okay, so we need to have one of these choices. Inside the story node. All right, so that's basically the data structure we're going to need. So we just need to start making some functions to use them. So the first thing we'll need is a way to add choices to our story node, because we're going to be doing that a lot if we're going to build up a story. So let's do. Then we're going to use the receiver types that we learned about before. So call it node, story node. And we'll call this add choice. And a choice is going to need a command string, a description string, and the node that it needs to point to. So we're going to do command, which is a string, description, which is a string, and let's see, call it next node. Let's call this next node too, just so it's consistent. We can call this next choice. So we'll do next node, which is a pointer to a new story node. All right. So the first thing we need to do is make this choice. So let's say that the choice equals command, description, next node. And then the next choice will start out nil. This needs to be that syntax. And it's probably just complaining because we're not using it. Oh, we got to tell it it's new choices. Okay. Okay, then we need to check and see if our story node, the one we're currently in, if choices is currently equal to nil. And if it is, we'll just set our new choice to choices. Let's make this a pointer right away there. Okay. Else, we want to do is loop down the choice linked list until we find one that's null. So we'll start with choices. And while current choice dot next choice. Oh, we don't have while loops. Okay, so as long as the next choice is not nil, we're going to keep advancing down the linked list. And then once this loop completes, we'll know we're at the last item in the list. So we can say current choice dot next choice equals our new choice. Okay, so this is very similar to the add to end function we wrote before. And one point here is you might notice we're kind of recreating some of the work to make a linked list that's a little bit different. So the linked list we had in the linear story just had text and a next pointer, whereas this one's got extra stuff in it. You'll hear some people complain about Go not having generics. When you have generics, you can do things like make a linked list that can hold anything. So we could have written the linked list once and held both of these things. And there's a way to do that in Go as well, though you lose type safety on the linked list. So that's just something to know about. That's kind of what generics are for, is so you can make, or one thing they're for is you can make collections that can hold multiple types. Fortunately, a linked list is simple, so it's not that big a deal in this case. All right, we've got the ability to add choices. We're also going to want to be able to kind of spit out the text for a room to describe it completely, and that will mean printing out the description of the room or the node of the story with the text. But we also have to show all the choices somehow. So let's make a function for that as well. We'll call it render, even though it's just text. It still counts as rendering. So first thing we'll do is easy. We'll just print the node's text. But then we also need to print all the choices out. So we'll say current choice is equal to node.choices. So same kind of logic as we did here. As long as current choice is not equal to nil, we want to print line the command and the description, and then advance to the next choice. Let's see, why is this unhappy? Missing function body. can't put the curly braces there. Current choice dot command and current choice dot description. Okay, so this should print out the state of our node, all its choices. And we also need a function to handle when a user types in a command to see if it's valid and to make it happen if it is. So again, this will operate on a story node. We'll call it execute command, and we'll get a command as a string. And execute command is going to return a new story node. That'll be the story node that we move to once we execute the command. So again, we'll get the current choice, choices, and we'll loop just like before. But this time what we're going to do is see if the command that the user entered matches any of our choices. So there is a strings library in Go that we can use, and it's got a function built in to make things lowercase. So we want to make the commands case insensitive, so it doesn't matter if they type things capital or lowercase. So we're going to make everything lowercase. We'll make the current choices command lowercase. And then we'll check if that's equal to strings.toLower, the command that the user entered. Okay, so both are going to be lowercase, so they'll match no matter what case they started out as. So if the string that the user entered matches, then we're going to return the current choices next node. Right, that'll send the person to the next room or next phase of the story, whatever it is you've decided to build. Okay, and if this loop completes without having exited here, it means the user entered something that didn't match any of the choices. So we'll want to say something like, sorry, I didn't understand that. That is the kind of thing text adventure games used to say all the time, and it was kind of irritating. So then we'll just return the same node. So the user won't go anywhere. They'll have to enter the command again if their choice didn't match. All right, and then the last bit we'll need is a function to actually play through the whole story. So again, this will operate on the story node, and we can just call it play. So in order to play, we'll need to render the current node. All right, we've got that function ready for us. If there are any options, or any choices, then we want to read from standard input. And we're going to do something a little different here. So we're going to declare a scanner variable here. Pointer to buffio.scanner. This way we're only going to make a scanner once rather than making it over and over. So when the program first starts, we're going to say scanner equals buffio.newScanner os.stdin. Okay, and if you weren't on the other streams, this is just a function built into the core library, so it lets you read things in from different sources. We tell it we want to read from the standard in source, which means reading from the console or terminal. And you get this scanner that lets you do that. So we'll say scanner.scan, and then we will execute a command with whatever we got back from scanner when it scans. Scanner.text gives us the thing that the user typed in last. So that's going to give us back a new node. So we're going to recursively play with that. Now, if you're worried about your story having like 10 million nodes, then you might not want to use recursion. But probably even 10 million would be fine. Okay. So I think we're all set with the functions we need to do the text adventure. What's left is to actually build something. So I'm just going to build a simple one so that we can test and play with it. So we'll make the start, make a starting story node. So a new Go feature that we haven't shown yet. Previously, we've shown how you can make a new struct with this syntax, where you can provide all the arguments without names. You just put them in the same order, and you make sure you do all of them, right? So our story node has text and choices. So we can say text and nil, and that would work. But another way you can do it, if you don't want to do them in order, or if you don't want to supply all of the fields of your struct when you make it, is you can name them. So we can say text is whatever, and then you can leave the choices out, and that'll just set it to nil. Any field you don't set will be set to the 0 value, and for pointers, that's nil. So we can use that here, so we don't have to explicitly set those things to nil if we don't want to. So let's show another feature, which is if you want strings that are really long to cross over multiple lines, you can do that by using that single quote character, the one up by the tilde. I don't actually know what it's called. And so when you do this, you can do as big of a string as you want. So VS Code's doing strange things to me here. All right, this needs to be up here. Why aren't you happy? Oh, declared and not used. That's fine. We're going to use it in a minute. Okay, so first thing we're going to do is just make all of the nodes in our story, and then we're going to add all of the choices to them. So I'm going to have another room called dark room. Can't see anything in the dark room. We'll have a dark room once it's been lit up. So you can really do anything you want with these graphs. It doesn't have to just be rooms connecting to other rooms. It can be rooms changing to new states as well. And if you've played Zork, you'll be familiar with the GRU. They only come out at night, or in the dark, and they eat you. Bad news. So we're going to make lose and win states. All right, that'll be our win state for now. Okay, so now we need options. So let's add choice to start. We can go north. And if we go north, that'll take us to the dark room. We can go south. And just for fun, to show that we can do whatever we want with a graph, we can make that path go to the dark room too. It can be magic. It doesn't matter. And if you go east, you'll end up at the trap. Now we'll do some darkroom options. You can try to go back, but it's not going to work. You're going to end up in the GRU state. The O. Or you can turn on your lantern. That will change you to the darkroom lit state. So once it's lit up, if you go north, you'll win and get the treasure. Or you can go back the way you came and go back to the start room. And I think that's it. Now we're using all the rooms. Compiler's happy. So now we just need to play. Then if the game is completed, we can say the end or something. All right, any questions about what we're doing here? So let's run it, see how it goes, see if we have any mistakes. All right, let's make this bigger. All right, you're in a large chamber deep underground. We get all of our text. We'll see what happens if we go east. All right, we went east. That took us to the trap room. We fell into a pit. The end. So that worked. Let's try going south. It's pitch black. Let's try to go back. Let's try to go back. Eaten by a GRU. The end. That worked. Let's go north. Let's try turning on our lantern. All right, now the room is lit. Now we can go back. All right, back at the start again. So we can go in a cycle. It's a cyclic graph. All right, we got to keep turning on our lantern apparently. Let's try going north, and we win. All right, so we made a really simple game here, but the possibilities are really limitless. You could create mazes. You could just create an entire game based on dialogue options, where you maybe have to try to talk people into things or solve a mystery. Anything you want. And you can see that there were some limitations here. For instance, when we went to the dark room, turned on our lantern, left, and came back, our lantern was off again, right? Because we don't have a separate lantern structure where we're keeping track of the lantern state. Now you could still make that work, but you'd have to make like a whole separate set of nodes where like you go back to the start, but it's not the same start. It's a start where your lantern is on. So that could get really big quick. So there's lots of different features you could start adding to this. For instance, you could add the ability to have NPCs. So actually, I'll make some comments up here. So these will be like ideas for things to do. You can think of this as homework. So ideas for things you can add to this. You could add NPCs, stands for non-player characters, right? And maybe you could have some way to talk to them or fight them or something. So you could imagine like would have like a description, then maybe an amount of health, and you can devise some way where you can attack them or they attack you. You can get a little more tricky and have the NPCs actually move around the graph on their own. You can have items that can be picked up or placed in the dungeon. Another thing you can do is a lot of these games back in the day, rather than having this list of options, text. Rather than having a list of options like this, you could just type natural sentences into the game. You could say things like "go north," or you could just say "north," and you would go north. You could say "kill troll with sword" and attack the troll if there's a troll there. And it would it would parse that and figure it out for you. That's also something you could try. Is accept natural language as input. And to do that really, really well is very, very hard. But you could do close approximations where you just pick a few verbs you're going to accept. So someone is asking, can you register the choice without having to press enter? Yes, you'll need to use something other than this scanner. I am sure that Go's got some built-in stuff to do that. I don't know what it is off the top of my head. Pretty soon we're going to start using SDL2, and it's got stuff built in to handle keystrokes that way that we're going to use. That's the thing I'm familiar with. But yeah, you can look through the Go documentation and probably figure out how to just see if a key's been hit without having to press enter. Yeah, you can make a pretty decent natural language approximation if you just pick a few things, a few words you're going to recognize, and maybe require that you always have a verb and then a noun. So you could have, attack troll, and that would work. Some basic directions like north, south, east, west, up, down. So you can kind of keep that as simple or complicated as you want, but that can be a fun thing to try. Okay, so we've still got 30 minutes left. Are there any questions so far? Oh, well, I guess another thing you do for homework is just build your own game with this. Like just practice playing around, see what kind of things you can accomplish just with this system. There's really quite a lot. It might be a lot of work to do some things, but you can kind of do anything. It's like a big state machine. Sorry, my headphones like to turn themselves off if there's no sound. Okay, so since we have time, we'll go on to a second version of this, and we'll learn about arrays and slices in Go. So let's make a new folder out here in the root. Call it Text Adventure 2. And let's just take all of this. Or let's just copy the whole file. Rename it. You can hit F2 on a file to rename. Okay, so what we're going to do is we used a linked list for our list of choices, because we learned about that in one of our earlier episodes. But there's actually a better data structure to use for that in terms of performance, and also because it's built into Go, so you don't have to do it all by hand. So this was good to use for learning purposes, but we can change this to use arrays, or really slices. So let's talk about what those are a little bit. So in Go, let me clear this out. And in any language, really, there's going to be some concept of an array. So what we've used before, we wanted to have a list of things all in a line. So we used a linked list. And the way a linked list works is each of these nodes is going to be in a different location in memory. So like this node here isn't necessarily next to this node in your computer's memory. It could be anywhere. And that's good, because if you want to insert new things, for instance, put a new node in here, then all you have to do is get rid of your old link, wire up the new links, and you've inserted something. And the same thing for deleting. If you want to delete, you just get rid of 2 links, stick a new one in. That's no problem. So with an array, you also have a list of things, but they are guaranteed to be contiguous, or next to each other, in memory, right? So if you had an array of integers, it would look like this, and these would be actually adjacent to each other in memory, all one piece. So a downside of that is if you want to add a new element, right? If you want to put another 3 in here or something, is first of all, if your array is full, then you have to make a new one. So right, step 1 would be make a new array, right? With enough room. It's got to make it bigger. And then you could insert, an extra 3 in there. Now, even if you already had enough room, right? Let's say you had some extra room and you wanted to insert, you're still in trouble, because you have to shift everything else over. You got to move this 3 over and that 4 over, then you can insert your 3. So that seems like a lot of work. So you might think, why would you ever use an array if you have to do all this extra work if you want to add things or delete things? You have the same problem if you want to delete. If we want to delete the 2, then we have to move all this stuff over too, right? And the reason is because you can go through your list, you can iterate through it much, much faster with an array than a linked list. And the reason is because your CPU is very fast. So if you were to do like kind of speed on the graph here on the y-axis and time. So over the years, CPUs have gotten faster, like this, or even super linear. But RAM has gotten faster, much, much slower. Every time you have to get something from RAM, your CPU has to wait for as long as like 100 to 200 cycles. So you could have added 200 numbers, but you can't because you're waiting to get something from RAM. And so when you go through a linked list, each hop you make, you might have to go to RAM, because this could be anywhere in memory. But with an array, the way computers work, modern computers work, is when you ask for something from RAM, so if this was 1, 2, 3, 4 again, 2, 3, 4, 5, when you ask for the 1, the computer takes a long time to get you that 1, but at the same time it gets you a big chunk of RAM. So it's actually going to get you that 2, 3, 4, 5, and then the next 64 numbers usually, all at once. And so when you need the 2, it's already there. When you need the 3, it's already there. And as you go down the array, these things are streaming in from RAM really fast, and you don't ever have to wait. So whenever you're only occasionally adding and inserting things, it's usually faster to use an array because you can go like hundreds of times faster iterating through them a lot of times. And also, arrays are built into Go, and they are generic. So while Go does not have generics that you can use on your own types, arrays are generic, and that arrays can store any type you specify, and you get type checking on it. So let's just go through the exercise of converting this to an array and see how that would work. So the syntax for an array we're going to rename this to choice. All right, so this tells it we're going to have an array, or actually in this case a slice. And I'll explain the difference between arrays and slices in a second. And actually, let me go ahead and do that. Let's do some smaller examples first with arrays. We'll just do them down in here. Okay, so this most straightforward way to make an array. So we can make an array of strings. So this tells it we want to make an array that is 3 items long, and then we give the type for the array. And if we want to make it straight ahead, we can go ahead and supply the values we want. So we have to supply all 3 values and no more than 3 values. Okay, so now we have an array of strings called ABC that's 3 long. Now the problem with this is you might want to have like a function that prints an array. And the problem is if you want to use an array, you have to specify the size. The size is part of the type. So you could print the array like that, but the problem is it can only take ones that are 3 long. So this will work. But if you wanted to make one that was 4 long, that print array can no longer handle it. So that's kind of useless if the arrays have to be the same size all the time to use them in the same functions. So you don't actually use arrays very often in Go. What you use instead are slices. And you can make a slice pretty easily by just not specifying, or actually, no. Oh, yep. Not specifying a size. So now ABC is a slice. And our print array is still expecting an array. So we need to make this a slice as well. So now it's happy. So what slices do for you is slices know about their own size, for one. And also you can, Go has things built in to make them bigger or smaller. So for instance, if we wanted to add something to ABC, there's a function called append. So we give it ABC, that's what we want to append to, and we can give it a new character. Right, and that'll now append ABC onto the end. And just like I was showing before, if the array has room, so this was ABC, right? If the array has room at the end, it'll just tack on the D. If the slice does not have room at the end, then what Go will do is it will make a whole new array that does have room. And I'll usually do that by making it twice as big. So let's say it was 3 big, so now it's going to be 6. Then it'll copy the elements over, add the D, and then this will get garbage collected later. Okay, so all that stuff you have to do with arrays, Go will do that for you with the slices when you use things like append. Okay, and there's lots of other things you can do with slices. Like slices can, you can take slices from other slices. So if you wanted, let's say you had your A, B, C, D, but you wanted to like pass around just the B and C, you can make a new slice that just points at the B and C. Lots of stuff you can do, but we're just going to use the basics for now to try and make our text adventure more efficient and maybe a little bit simpler too. So let's go back up here, change this to choice. It's no longer going to have a next choice because we're just going to use an array of pointers to choices. Okay, so now that we've changed that, we have to change all the functions that use it too. So to add a choice, this should actually get a lot simpler. We're still going to need to make a new choice. We won't need the null pointer anymore, or nil pointer anymore. And then we'll need to use that append function. So we'll say append or node.choices equals append node.choices. We'll append the new choice. All right, so that saves us a bunch of code. Then we need to do the render function. So this will stay the same. We will not need this anymore. We still need to check to see if there's any choices at all. So if choices is not equal to nil, node.choices not equal to nil. Okay, so now we're going to see a new feature built into Go called ranges. And so what that means is we can make a for loop. It's like a shorthand, basically. So this is the new keyword, range. So range can operate on arrays and a couple other data types built into Go. And what it does is range knows about arrays, and what it can do is give you each element of the array in your for loop. So if choices has 3 elements, it's going to give you each element and loop through the array each time, once for each element. And it can also give you the index of that element. So arrays are always numbered, and they start from 0. So our ABC array is going to be numbered like this. These are the indexes. So you can get at whatever part of the array you want by supplying the proper index. And this range function can give you back both the index and the element itself. Often both are handy. If you don't actually need both of them, you can use an underscore in place of one, and that tells Go you don't care. So we don't care about the index because we're not going to use it. So we're going to tell Go we don't care about the index. We just want to iterate over each of the choices in the array. And then for each choice, we're going to want to print line the choice.command, choice.description, and that's it. Oh, it's not in.choices, it's node.choices. All right, so I think that's it. So then execute commands is going to be similar. We can steal that same for loop. Except here we're going to say if strings.toLower choice.command equals strings.toLower command. Then return choice.nextNode. Okay, then if if none of the choices match, then we say I don't understand, return just like before. And then to play, what do we do to play? What do we do to play? Yeah, play stays absolutely the same. And I think that's it. So let's give it a try. Let's go to text adventure 2. Go run text adventure 2. Go. Let's try go north. Turn on the lantern. Go north again. All right, so we're back to running. So this is a more efficient implementation in terms of runtime. Potentially, it could be slower actually for adding choices, but playing through it will be faster, and rendering rooms will be faster. But more importantly, it's just a little bit simpler, right? We can use a pen rather than having to walk down the list ourselves, and we can use these the range shorthand, which makes things simpler as well. And the main point is start learning a little bit about arrays, because probably the next thing we're going to do is start doing some graphics with SDL2, and we'll be using arrays all the time with that. So getting a little bit of an introduction. All right, so now with this, you guys can try some things. If anyone builds a game with this that they think is kind of fun, you can post it up on a gist next episode, and we can at the start of next episode we can play through a couple of these. So if you're not familiar with gist, it's like a free GitHub feature. It's nice for just pasting code in and sharing it. It'll do nice syntax highlighting and stuff. And you can just post links. So yeah, make a cool game. If you want to add some of these features, you can, but you don't have to. And we'll play some at the start of the next episode. Any questions before I go? We got 5 more minutes. All right, sounds like no questions. I will see everybody, I guess, on Sunday. And I think what we'll start doing next is start doing some graphics. We're going to use SDL2. Most of the time might be taken up with setup There's some setup stuff we'll have to do for it, but we only have to do that once, and then we can start drawing pixels. All right, goodbye, everybody.